Alright, on page 28. Measuring angles. Alright, couple definitions. Talking about an angle is formed by two rays. Which are the sides of the angle. Their endpoints are the vertex. Yes. You don't have to ask. Yeah. This portion of the angle is the interior. And everything out here would be considered the, very good, exterior. Top of page 29. Naming angles. Alright, there's three angles in this diagram now. When you're naming an angle or describing an angle, you're going to use three letters, or you can use the number that's near the vertex of the angle. So one of the angles that we have in this diagram is angle JMK. The vertex of the angle always needs to be the middle letter in the description. Angle JMK in this case is also angle 1. Another angle in that diagram is angle KML, or angle 2. The third angle in that diagram is angle JML. Any questions? Yes, sir. JML can be called JML, or it can be called angle LMJ. But you can't call it angle 2 because angle 2 is KML or LMK. Okay. Angle 2 is this angle right here. And angle 1 is this angle right here. And neither of those are the big angle, are they? Now, while we're here and we have this diagram up here, we're going to talk about the angle addition postulate. And the angle addition postulate is like the segment addition postulate that we talked about last week. In this case, it means angle JMK plus angle KML is going to be equal to angle JML. The smaller angle up here plus the smaller angle right here equal this big angle right there. You can also say that angle JML minus angle KML would be equal to angle JMK. And can anybody tell me what angle JML minus angle JMK would equal? Angle KML, very good. That works the same way as the segments that we dealt with last week. All right, the big angle, that big angle right there, minus one of the little angles equals the other little angle. Questions? Always. Yes, sir. All right, some more symbols and notation. You got an angle. Now, since there's only one angle in this diagram, we can call it angle A. You can just use the vertex to describe it. So your notation for the measure of an angle is a lowercase cursive. The measure of angle A equals 40. The lowercase m in front of the angle symbol stands for measure. The measure of angle A equals 40. All right, look at the top of page 30. A couple more definitions. We're going to talk about an acute angle first of all. Let's see, acute. That's less than 90 degrees. And you've got a right angle. And that's equal to 90 degrees. Obtuse. That's greater than 90 and less than 180. Finally, you have a straight angle. And that's equal to 180 degrees. So in this case, angle ABC is what kind of an angle? It's obtuse. All right, and the measure of it is 120 degrees. Good. All right, congruent angles. Congruent angles have the same measure. This little red arc and this little red arc mean the angles are congruent to one another. And you can say that angle A is congruent to angle B. If angle A equals 50 degrees and you know that they're congruent, then angle B equals 50 degrees. Any questions on anything we've talked about? A lot of definitions, a lot of terminology, but it's all important.